Good afternoon, everyone. We regret the inconvenience, but we have with us our eminent speaker today, Professor K Shinawatra Raju. I'll just give a brief introduction about Sir. Dr. Raju Sir is presently working as Professor in Department of Civil Engineering at Birla Institute of Technology and Science, Pilani, at Hyderabad campus. He has done MTech from IIT Chennai and PhD from IIT Kharagpur in Water Resource Engineering. His research interests include impact of climate change on water resources system, multi-criterion decision making, and soft computing application in water resource engineering. He has published more than 130 papers in various reputed journals and conferences. He is editor of Journal of Water and Climate Change, IWA Publishing, and associate editor for ISH, Journal of Hydraulic Engineering by Taylor and Francis. He is reviewer for more than 44 international journals. He has co-authored 3 books with Professor Nagesh Kumar Sir. He has completed many independent collaborative research projects, and at present he is working on a collaborative sponsored project, rainfall runoff modeling for Lower Godavari Basin in a changing climate, with IISc Bangalore, sponsored by CSIR. We are delighted to have with us an experienced academician by profession and a keen researcher by interest to walk us through the lanes of soft computing techniques. I humbly invite Professor K.S. Raju sir to take the session ahead.
Okay. Thank you, Vipin. How much time will you have myself?
Sir, it would be nice if you can complete by 2:30, sir.
Perfect. Perfect. Yeah. So, first thing, sorry for inordinate delay due to the network issues and exactly matching our fuzzy logic and application topic because everything is imprecise, in principle. Okay. So, my presentation will be, I will discuss about the membership functions and I will talk about the how to form linear programming problem. Then I will talk about how to handle the fuzzy logic problem and the further work. And if anybody interested, I will be available from 5 to 5:30 on the same Google Meet. Anybody having discussion, you are always free. Feel free to talk to me. 5 to 5:30 today. Thank you. Now, when talking about uncertainty, in fact, the topic which I am planning to give is fuzzy logic and applications. The first is that what is fuzzy? Fuzzy is nothing but what? A typical imprecision. Imprecision means what? Not certain, in fact. If you see any dictionary, the meaning of fuzzy is exactly showing like a imprecision, or if you want to be still more specific answer in the uncertain topic, it is very clear that it is not certain, it is not clear. Then, so you may ask me, sir, what type of uncertainty we are expecting maybe in the water research, civil engineering, or in general? There are multiple ways of uncertainty causes. In fact, at the end of the day, what we are trying to do some type of a model. At the end of the what is my interest actually? Whatever data coming to me, I am trying to do some modeling for the better results. So having said so, the logic is that the first uncertainty, in my opinion, is unquantifiable information. Some information is there, but I cannot quantify it. Which means what I will do, I will approximate with some number. Typically, incomplete information is there, but it is not complete. What I will do, I will assume some information because at the end of what I told you, I want to model in fact. Typically, the non-obtainable, I cannot get some information in principle. I cannot get at all. For example, I want to check the infiltration of a certain area. I am not get it. What I will do, I will approximate maybe the nearest star, I will assume some value, etc. At the end of the day, all these things make my data what? Uncertain. Is it right? But at the end of the day, I want to modeling. What modeling? You take any modeling, you do optimization, which I'm going to tell you a little bit later, or hydrological modeling. So at the end of the day, my inputs are technically not precise, which means what? My inputs are imprecise. Due to this, whatever it is I mentioned here, at the end of the day, what is happening here? Input, modeling, output. Then what is understanding? Whatever output also expected to be imprecise to some extent. Then you may ask me, sir, can I say modeling with a lot of preciseness? Technically, I am not really sure whether the data coming to me is really precise or not. There are number of reasons for this. So then option number one, ignore the concept of uncertainty, assuming everything is perfect. We can assume that everything is perfect and then model it. In my opinion, which is not logically true, then handle the imprecision in the best possible sense. So the topic which I am just taking to discuss in the time given is about the one of the approach which I have taken in the concept of the fuzzy logic. So I start with fundamental so that it will be easy to understand. Then if there are two ways of seeing the uncertain, one is called crisp logic. Most of things you would have studied about the set theory. What is crisp logic? Happening, not happening. If you want to drive a car, you can say car is going slow, car is going fast. Two options, two extremes. But in the reality, what is happening here? I can make it right. Car cannot be slow to fast immediately. Is it right? It takes slowest. You will start your car, then become slow, fast, fast. What I'm trying to convey here, the transition is abrupt. Your transition is very smooth. So that means what? I am trying to bring a lot of flavor whenever I'm trying to handle the uncertainty. Which is certain? Somebody asks you, have you passed or not? One answer. So most of the time, this is more practical, no ambiguity. Is it right? Things are well defined. Today rain will happen or not? Sir, happens. Today rain will happen, sir. Rain will not happen. That is straightforward answer. What other option? Sir, rain is likely to happen, sir, based on yesterday's information. Whenever I am trying to make some type of what I would call a natural language, which is more appropriate for most of the modeling situations which you are trying to handle in the today planning situations. Then if somebody asks me, sir, you are talking about uncertainty, sir, how to handle uncertainty? Uncertainty handling, you can handle it multiple approaches. For example, somebody say, sir, I will give simple example. How many marks you got it? I will say, I got 42 marks. But I'm not really sure whether I'm telling the logical value or not. That means whatever information coming to me, first I want to believe the number. Second is what? Sir, how many marks you got it? 42. What is the range? Range is 40 to 50. What is meaning of range here? Is 42 also may be there, 43 also may be, 44 also will be there. Some type of an interval. That means what? I'm trying to accommodate uncertainty in the form of an interval. After what these are called p-values. Somebody say, sir, I got 42 marks. Even though therefore you're not telling me the truth, I will simply say, okay, it is around 42, which means what? It will be 40 also, 50 also. This is called the uncertainty representation in the form of a membership functions. Like this, you can define any shape. What is membership function? It is your thought process of handling uncertainty. If, sir, if everything is certain, I don't have necessity of this type of approach at all. Everything is certain. My problem is so straightforward. But since we're all civil engineering background, we know that a number of uncertainties will be there in the data collection, data processing, data analyzing. So these uncertainties are not most of the time are not additive uncertainties. Remember, these are sometimes called and cascading. Cascading is what? Everything is little bit complex. That means if I do one mistake, the mistake may not be plus of other mistake. It may be exponent mistake or some other. So what is membership function in the fuzzy logic? Membership function is nothing but trying to explain a one type of uncertainty. So you can see here, this is a typical, please, what is membership function? I told you, a typical graph, typical plot, whatever geometrically possible for you to draw coordinate geometry, that many membership functions you can create here. Then, what is x-axis, what is y-axis in membership function? Very simple. X-axis is a physical value, y-axis is your the membership function. What is membership function? I told you, your thought process. Or people call membership function in the form of a degree of satisfaction. How much degree of satisfaction you will have? 100% satisfaction. Maximum, is it right? Minimum how much? It may be 0. In between, it may be 0 to 1. That's why I told you in the CRISP logic, what is my option now? 0 and 1. Fuzzy logic, 0 to 1. 0 to 1. Remember these understandings. 0 and 1, 0 to 1. So 0 to 1 is more appropriate for me to handle the problem or to handle the uncertainty in the problem. Then, so that means what? Whatever uncertainty is there, I am trying to show in the form of a certain geometrical shapes that I am calling as the membership functions. Membership functions. So for example, I have taken here the Z. Z is nothing but what? One objective function. What is objective function? Let us assume a benefit objective function. So what is the lowest value of the benefit? ZL. Highest value of benefit? ZU. But in between what I told you, ZL and Z two entities. In the CRISP logic, ZL is one entity, Z is another entity. But what it is in fuzzy logic, what I mentioned, my this Z value varies between ZL and ZU. That means what? It may take ZL also, ZU also, in between ZL and ZU. Any value in between ZL and ZU. So typically you can take membership of two types. One is for maximization. That means what? I prefer more. I prefer less. For example, somebody gives me more money. I prefer more money, most probably. Is it that means what? If I got more money, my satisfaction value is 1. If I get 0 money, my satisfaction value is 0. Or if you take up this same example, the lowest value of ZL is nothing but what? Degree of satisfaction is 0, highest value is 1. In between, it may vary from 0 to 1. Typically, that means what? Highest benefits are preferred. Again, you come to this figure. What is the figure? In fact, the cost aspect. What cost aspect? Lowest cost is preferred. Is it right? I purchase the item which is having minimum cost. That means what? When an item is minimum cost, I'm very happiest person. If somebody gives me freely, I'm still more happiest person. Is it right? So this is membership functions are nothing but what? Representing your thought process. Representing your thought process. Then what are the equations? These equations are nothing but what? Whatever you have drawn here, a graphical pattern, you are trying to draw again in the form of what? In the form of what? A equations. What is meaning of z less than zl means what? What is mu zx? Mu represent your membership function. Z means the corresponding object function. X is relation vector. If z less than equal to zl, you can see here what is the value here? 0. If z greater than zu, what is the value here? 1. In between what? In between what? Z minus z minus z. This is nothing but equation of your straight line. Equation of your straight line. Nothing else. Nothing. Anybody wants this to work on fuzzy logic, you can come to me today 5 o'clock. I will give you more tips how to start your fuzzy logic research directions. 5 to 5 that I will available. Then what exactly the opposite side? Whenever the cost is less than, my preference function value is 1. If it is greater than ZU, what is happening? I'm not happy. When cost is increasing, I'm not happy at all. That means my degree of satisfaction is coming down. Is it right? I told you these are nothing but typical natural language option, typical natural languages. Then, so this is one type of, I will call a non-linear type of membership. Why non-linear? It may be the ZL and ZU, the relation between Z and Z may vary linearly also. It may take any other shape also. It may be convex also, concave also. That means what? In the body equation, body being a straight line, I'm assuming that the variation of ZL and ZU is straight line. 3 mangoes, 6 rupees, 6 mangoes, 12 rupees. But what other possibility? 3 mangoes, 6 rupees, maybe 6 mangoes, 5 rupees also, because or 7 to 8 rupees also. Meaning of that, it is a non-linear fashion. So either you can think of varying linearly or the non-linearly, depend upon your problem, how you are defining your problem. So this is the way you're increasing your, this is, I told you, this is what this membership function equation, but mainly for what? The maximization perspective. What is maximization? Maximum happiness. Is it right? Yes. So happiness like this. So like similarly, I told you whatever possible in geometry, coordinate geometry, the figures, that much easily you can make your membership functions. I told you this is what? This assuming that your membership fund thinking process in the form of a triangular. In this case, what is happening here? Something increasing, something decreasing. Why triangular? Up to certain point, you want it, beyond that, you don't want it. Typically, this is a trivial membership function. I told you, whatever problem you pick up, think logically, how your thought process is varying. Or you can ask me, sir, instead of straight line, can I make a curve, sir? Can make anything. That means what? You are assuming the variation between A1 to B1 is not straight line, it is following certain a curve order like this. Typically, it is the trapezoidal. Like this, you can define any shape of membership functions which are available in the what I can call the coordinate geometry. So this is nothing but what? A simple hyperbolic function. Typically, you can make a simple exponential membership function. What you require here? You require one for the what I can call the z less than zl, z greater than zl. These two are fixed. What is going to happen? This membership function between the zl and zu only always your interest. In the fuzzy logic, then always the interest is what? What is happening beyond below zl? I don't have interest. Anyway, it is zero in the case of maximization. In the case of maximization, what if I don't have interest? What will happen after ZL? Because that is 0 and 1. I told you. My satisfactions are very much fixed. Is it right? If I won't get anything, I am very sorrow. If I get everything, I am very happy. That is two things. That's why I told you called a crisp logic. Crisp means what? Fixed. Are you happy? You got 1 mark. Are you sorrow? You are 0. But fuzzy logic, what it trying to bring? It trying to bring a corridor between what? What is your status in between it when it is vary. That is the crux. And you take any example of fuzzy logic, engineering, civil engineering, any engineering management, you can do a lot of wonders. Now, what I'm trying to tell, I will tell very briefly about optimization because that is very much required for me when I'm teaching you the fuzzy optimization. So, what is optimization here? If you see, you open any dictionary, the meaning of optimization, I think you whatever best possible, what you mean of that, my resources are limited. Then what I will do, the best remains the best possible. Then nothing. It is actually I was given time of 1 hour in one. Typically, when I talk optimization, what I told you, any field of engineering, civil engineering, any field of any field, you tell the application, you fill the domain. For example, I want to design a canal. What is canal? A water conveyance system. What is the canal dimensions? Width and the depth. That means what? I want to supply the maximum water through the canal. However, I make some certain restriction about the width and the depth. So what are the decision variables in the canal? The width and depth are the decision variables whenever I am designing the canal. So again, so if you take up an optimization problem, I will call these are the 4 pillars. What is first what? Objective function. What objective function? My goal. Objective is my goal. Sir, I want to get 100 marks in this examination. That is my objective. What objective function? Whatever I am showing in the form of a mathematical relationship, I am calling that as a objective function. I am calling function. Is it right? Objective function. So whenever I want to achieve something, you will have some certain constraints. Is it right? What constraints? Realities. Is it right? Reality means what? I want to achieve something, but somebody is not allowing me to achieve something. If there are constraints, life is so beautiful, but most of the time we have constraints. That means what? So, for example, my lecture is up to 2:30, I will call constraint only. But what is my objective? I want to give the best possible lecture to all of you. Most probably the time. So, objective is my goal. Object function is nothing but the mathematical representation of my object. I will show you a simple numerical problems. What are the constraints? Constraints are hindering me not to achieve my objective the best possible. Then what are the decision variables which are controlling my problem? In the case of canal, what are the decision variables? I told you the width and the depth of the canal. What is optimum output? What are the optimum decision variables? The best possible decision variables I got. Let us canal, in the case of canal, the width and the depth. Whatever the width and depth I got, the best possible. If according to what is the corresponding objective function, I am calling that as a optimum output. Remember, in any of the physiologic problems, you will have the uncertainty in the objective function also, constraints also, of the every point of your modeling having some uncertainty. Very logically, that's going to help you make a best possible situations. Again, you can see there are a number of techniques to handle the optimization. It is nothing but your optimization. This is my function. What x next to? These are my decision variables. What is 2 and 3.5? These are my cost coefficients or object function coefficients. So what are these two? These two are nothing but your constraints. Why constraint? You can see greater than, less than. Somebody is stopping me, in fact, controlling me, in fact. Then what are 6 and 15? These are nothing but your resources. What are these x1 next to greater than? These are nothing but your bounds. What is in the bound? Bound is telling me or telling all of us, this is your limitation. This is your limitation. X1 should be greater than point or should be some type of a binding is possible. Is possible. If you understand the simple mechanism, most of the problems are then. So, what I will do now, a simple linear programming problem, which I framed in the optimization perspective, mainly in the linear programming framework. If this may take maybe maximum 10 minutes. After that, you will understand the whatever I am trying to convey fuzzy optimization problem much more better way. Then, so these are the, in fact, I want to grow 3 crops in a command area. But some land is available to me to grow the crops. Available with me 250 hectares. 250 hectares is maximum I can grow my crops. Then, after that, what I'm coming here? How much water available with me? 4 hectare meter water. What if hectare means 10 to the power of 4 meter square? This is how much water available with me? 4 hectare meter water only available with me. But if you want to fit an optimization model, what I require here? I require an objective function, some constraints, some bounds. If you remember this arrangement, all the one in the optimization. Nothing more than that. Then, so, but what is the three crops are there? What is the ultimate objective? I want to know how much crop 1 I can grow, how much crop 2 I can grow, how much crop 3 I can grow, or how much means what? How much acreage, how many hectares of crop 1 I can grow, how many hectares of crop 2 I can grow, how many hectares of crop 3 I can grow. Understood? That's all. That means what are the decision variables here? Acreage of crop 1, acreage of crop 2, acreage of crop 3. Remember that. That is only my agenda. That means what are expecting from optimization? I'm expecting the optimization. What is the optimum crop acreage I can get for the crop 1, crop 2, crop 3, and accordingly, what is the ultimate objective function value? Nothing else, nothing more than that. Then, so whenever we are doing optimization, we see here. So somebody say how you get x1, x2? X1, x2 values are coming such a way that your objective function space, your decision space, everything has to interact. Interact means what? Intersection. That means what? What x and x2 values are there? These shall satisfy these constraints, these bounds. Simultaneously, I wish to have the best possible solution. That means what? Once again, what are the crop areas I'm assuming now? X1, X2, X3. There are 3 crop acres I wish to have my output. So then, if I'm selling this crop in the market, for 1 hectare of the crop 1, I'm getting 2,000 rupees. Crop 2, 2,500 rupees. Crop 3, 1,000 rupees. And I am spending some expenses to grow the crops. What type of expenses? I have to purchase some seeds, I have to purchase some water, etc. I have to provide land preparation, a lot. So what I will do? How much I am getting the gross benefits? I am subtracting all my costs. You can see in the table like this. Is it right? Per hectare, crop 1, I am getting this much, crop 2 this much, crop 3 this much. These are my costs. This is my net benefits. Then remember, so this is my net benefit I am getting for crop 1 per hectare, crop 2 per hectare, crop 3 per hectare. Then, so, and I told you what are the constraints? Land is one constraint, water is another constraint. 2 constraints I kept it for your demonstration purpose. Then, how much, technically, how much each crop requires per hectare water depth? What is water depth? Technically, crop water requirement. For 1 crop requires 0.03 meters per crop 1, 0.03 meters for crop 2, 0.01 meters for the crop 3. Is it right? So that means what? How much water required in principle now? 0.03 x1 plus 0.02 x2 plus 0.01 x3. But how much water am available here? 4 hectare meters. So you can see I am keeping my constraint. What is the constraint? What is the first constraint? 0.03 x1, 0.0 x2, 0.0 x3 less than or equal to 4. What unit of this 4? I told you hectare meter, volumetric unit. So this is my one constraint. What is the second constraint? The crops which are planned to grow, it should be less than or equal to 250 hectares. You can ask me, sir, why keeping less than or equal to? Why can't equal? I prefer to use this flexible constraints. If you make equal, it may not satisfy, or sometimes solution may be infeasible also. That is the reason we try to keep here less than or equal. Then what is my function here? 3900 x1. What 3900 x1 here? 3900 per 1 hectare. How many hectares I am planning to handle now? X1. So 3100 x1 plus 73 x2 plus 535 x3. So this is my objective function. These are my two constraints. Is it right? But then what are my bounds? What are my bounds are saying that they say x1 should grow minimum 40 hectares, maximum how much? 90 hectares. These are called the bounds. If you see our model is exactly moving in a same, I mean, objective function now, constraints as well as the bounds. You can see here exactly the same thing happening. So my model is ready now. So model, I will call model. Which model I will call you? This model is nothing but a linear programming based optimization model for the irrigation planning problem. Irrigation planning problem. Nothing else, nothing more than that. So what is my interest? I told you, my interest is to find out what is optimal value of x1, optimal value of x2, optimal value of x3. Is it right? Three values. And at the end of the day, what is optimal value of my objective function? You take any model, at the end of the day, sometimes your model will be an objective function, certain constraints, certain bounds. Philosophy is exactly the same way. It may be sometimes 40 constraints, 50 variables, that is different process. But the structure, the philosophy of optimization is exactly the same thing. So this is the problem. I should solve it now. Solving for what? Solving to find out value of x1, value of x2, value of x3. Is it right? That's all. Then, so for that I can use any solver. Solver is nothing but a simple software, or simple, you can solve using a very simplex algorithm. Whatever you can do that. I solved using a solver. So this in a model looks like my objective function, two constraints, remaining things are the bounds. So what is expected now? Expected nothing but x1 value, x2 value, x3 value. What is x1 value? 46 hectares approximately. x2 value 100 hectares, x3 value 60 hectares. Then what is the object function value? You got it? 265, 766 rupees. So on what basis we got it? Based on the object function value, based on the constraints, based on the bounds. So this is a typical simple optimization model formulation. If you by this type very clear, you can do a lot of wonders. Then, so the other point, since I wish to tell a fuzzy logic and fuzzy logic optimization problem before going to case study, I will tell you what is multi-objective. What is multi-objective problem? Whatever I shown you previous problem, what is no problem here? Single objective problem. Single objective problem is what? I am having only one goal. Somebody saying, go get the money over. Is it right? Single objective. Single objective problem is what? Things are comfortable to me the best possible way. But sometime what will happen here? I am having interest to solve more than one object. Because fuzzy optimization, in my opinion, will do wonderful things when you're trying to link with a multi-objective situations. Then, so then what is multi-object? I told you, I am having more than one object. You may ask me, sir, do you think more than one object really required? First thing is, most of the problems it is required. Then, if somebody say, sir, can you give an example in the multi-object problem? Let us assume in the irrigation planning problems. I work on a lot of irrigation planning problems. I always see that you can take, or you take reservoir operation. What is the objective objects in the reservoir operation? Maximize benefits, or maximize irrigation benefits, or maximization of what? Hydropower production. Is it right? Both are conflicting objectives. Most of the time, both are conflicting objectives. Sometimes people say one more objective they will bring. There should not be any minimization of environmental impact. What I am trying to convey, same problem, same case study, but what is changing? Your thinking process changing. Your constraint remains same. Your bounds remains. Everything remains same. What is going to happen? What is changing the multi-objective problems? Most of the times, my thinking process changing. Yes, my goals are changing. Is it right? Simultaneously, somebody say, sir, can you do? They will say, you do this work. Okay, I will do it. Somebody say, you do this work also. When? Same time. Somebody give me 1 hour time, sir. Please prepare assignment clearly. I will prepare assignment because somebody told only one direction. You need one direction. Somebody say, sir, I'm preparing assignment, sir. Do this correction also. What is happening here? My resources remain the same. My objectives are different. So what I will do? I will prepare assignment as a namesake. I will prepare correction of the paper a namesake. But one objective, okay. Second two objectives, I try to compromise it. Is it right? But you may ask me, sir, is it possible? Most of the regular problems are multi-objective problems. Multi-objective problems, moreover, depend on the case study, will have even somewhere we'll have the impreciseness also in the data. The situation is that my resources are imprecise, my objective functions are imprecise. But I assume most of the time my objective functions are imprecise. Why? Even though your constraints resources are imprecise, it at the end of the day it is affecting your objective function. That is the reason most of functions are the imprecise. That's all. So when talking about, I told you what? It tries to handle some type of uncertainty. So I told you what? One deterministic fudge. What deterministic I told you? Everything at the end of the what? If you remember, I told you one figure, one problem I showed you. What I told you, how we get x1, water x1, x2 I am getting, or water x1, x2 which I am calling optimal. These are nothing but what? Which takes care of the constraints and the objective function. And underneath what? I cannot simply say x1, x2 value without bothering about objective function. That means what? That means what? I am trying to handle my problem in terms of constraints and objective function. Remember, constraints and objective function. Then only I will have the logic of finding of the x1 and x2 values. If I remember under option, my fuzzy logic part is technically very, very clear. So what fuzzy environment, what is happening here? I am calling fuzzy objectives. What is fuzzy objectives means what? I am assuming my objectives are not precise or my constraints are not precise. Then you can say, so how will the constraint not precise, sir? But I am not really sure that every time my constraint will be always 4 hectare meters. 4.1 hectare also will be there. 3.1 hectare also will be there. I am not sure that 4 will be always constant. That is the reason that I am assuming that water happening at the end of water onset happening, it is happening, and at the end of the day, these are impacting my objective function values. Objective function values. So that's why I told you, whenever you are going for a fuzzy logic operations, you always use the word water. And I told you the fuzzy logic, we are using the word concept called the intersection. Intersection is what? That is nothing but the minimum operator in the either special theory or fuzzy set theory. So I am showing small mathematics, very simple terms. What is the D? D nothing but my decision space. What decision space here? In the case of my example, x1, x2 is my decision space. What is the G? My goal. What is the goal here? Object function is my goal. What is C here? Constraints. What I told you, how we got x1, x2, optimal of x1, x2, which satisfy the constraints, which satisfy my objective function. That only I am calling as the decision space. This is in terms of what? In the deterministic approach. Deterministic is what? Everything is certain, no issues at all. Water problem I have shown you, this is what? A typical deterministic problem. Always my objective function value remains same, my resource remains same, these values will never change. That is called the precise situations. So what I am trying to do now, I am trying to handle the problem in the form of a fuzzy. And what is fuzzy? I told you, imprecise environment. So, but what is the new? I told you is nothing but what? Representing in the form of an imprecision. What is meaning of what is imprecision here? I am trying to handle impact of imprecision on my decision variables. What is the new? Imprecision in the objectives, imprecision in the constraints. For example, if I am having 10 objective functions, how my equation looks like? Equation looks like, you can see my decision space remains same. Objective one and similar. What is VC1? constraint, and. So what is the decision space? I told you, the decision is expected to handle intersection of all objective functions, all constraints. Or what is operator? What is operator? I told you, the minimum operator, which is meaning of that mutex is nothing but the minimum of all the objective functions, all the constraints. But what I told you, I want the maximum decision space, the best possible decision space I wish to have, which is meaning that the maximum the decision space, or I am writing this in terms of mu d star. What is mu d star? Optimum decision space, or you can say mu x is nothing but what? Maximum of minimum of all these values. You can see here. So what I told you till now is simple approach. What simple approach I told you? A simple mathematics where I am expected to handle all the objective functions, all the constraints simultaneously. But since when I'm calling multiplicative problem, what is multiplicative problem? I'm having more than one objective function. Is it right? That's called multiplicative problem. And simultaneously, I told you whenever multiplicative problem coming, what is my understanding? My understanding is that all the objectives are expected to satisfy simultaneously. That's the reason I'm using what? And like this. So what I'm trying to see mu dx, I am trying to represent in terms of a dummy variable called lambda. What is lambda? Lambda is a dummy variable representing your degree of satisfaction. What is maximum of lambda? Degree of satisfaction 1. What is minimum of the lambda? 0. So you can see here whatever multiplicative problem I'm trying to convert into a simple, a beautiful problem. You can see what is the objective function of maximization lambda. How this lambda came? Maximization of udx. Then subjected to what? My objective function, my constraints. If I assume that if there are no uncertain constraints, this particular bundle can be nullified. But at the end of what I told you, what representation happen in the constraint at the end of the day, it is going to affect your objectives. That is the reason in this particular problem, I assumed that one objective functions are precise. I assume that constraints are not imprecise. You can assume that also. Simple mathematically improve it. What is the range of your lambda? 0 to 1. What is lambda? I told you, degree of satisfaction. Plus whatever existing constraint bounds are there, that will be applicable. So I prepared a small problem for your benefit. I have taken this object function for this particular problem, which I called a non-linearity. Beta also, what is beta? I told you beta becomes 1, the problem becomes what? Linear. Beta is other than 1, problem becoming a non-linear. Simple, I am not complicating the problem. Everything is simple, cakewalk. Then, so this I already told you about the mathematics behind it. I have taken the same optimization model. There are two crops are there. What is my goal here? My goal is to find out optimal value of the crop acreage x1, x2. How many objective functions am I having here? Objective function net benefits, objective function 2, agricultural production, objective function 3, labor employment. 3 objectives I am having. So again, what I shown, I formulated my optimization for like this. My objective function z1, z2, z3, 2 constraints, 2 bounds for the given data. Then what is my next agenda? I in the form of a multi-objective problem. Remember that my water uncertainty is following a membership function like this. That means I am assuming that my membership function for this problem following order like this. Z minus ZL by ZU minus ZL. So this is my, what is mu ZX I told you? This is my degree of satisfaction for the objective function Z. Having said so, you can see what I am doing now. I am not doing improvement of the thing. So Z1, Z2, Z3, I am converting this Z1, Z3 in the form of the membership functions. So membership function for objective 1, objective 2, objective 3. Why beta 3 I have taken here? I assume that beta 1 becomes 1, this problem becoming a linear. If beta 1 becomes a non-linear, problem is beta 1, beta may be any other value other than the 1. So whatever I shown you sometime back, a simple mathematics of here, you can see here, maximization of, you can see here, lambda, objective function constraints, objective function bundle, limitation, and the existing constraints. The problem becomes a simple a problem of the optimization. This is my maximization of lambda. I mean three objectives, is it right? Objective 1, object 3, greater than lambda. 1 as well as existing constraint set. These are my existing constraints and the bounds. So this will follow this particular problem. If you want to summarize it, your model looks like this. How much beautiful it is, simple format, simple problems. Because I am having uncertainty, I am also using the existing mechanisms. So the maximum lambda is what? The maximum degree of satisfaction I am getting, and most happiest man. So what I have done here, I am solving you solver. You can see I have taken beta to beta 3, which is meaning of what? Problem is linear. Beta 1 somewhere, problem is non-linear. What is lambda? Degree of satisfaction. Higher the degree of satisfaction, that much the better you are. But that much better your model is. So in this particular problem, what is degree of satisfaction? 63.63. Then you may ask me, sir, how much logical it is? Because what I'm trying to do, I'm trying to satisfy the degree of satisfaction like this. What is 6.63 meaning is what? 63 meaning is what? 63% of the time, all three objectives are satisfied. That is the way, that means higher the better. Higher the better. Now, I will explain, I may another 15 minutes time, I will explain a case study. Very simple way I will tell you. I have simply taken a case study of Srinivasan project. Srinivasan project is in Telangana, a very major project in Telangana, in fact, having a requirement of irrigation, drinking water, hydropower, etc. So what I saw using same problem using the fuzzy optimization for a better understanding. So here I take three objectives. The first objective. So what is this? In this particular command area, there are 16 crops are there. One A, the grass bin. What is A? The important decision variable, nothing but what? The area of the crop. Minus surface water cost, minus groundwater cost, minus. So what is maximum? This is nothing but what? The net benefits. This is a practical problem. Typically, I want maximum production, maximum labor, employment. You can take any number of objective functions easily. That is the advantage of fuzzy logic, because if you take one more objective function, what will happen here? At the most, it will come as a what? It will come as a one additional constraint. That's all. That if you take 10 objective functions also, it's becoming an additional constraints. Additional constraints. So, and again, like any typical problem, like any typical irrigation planning problem, I make certain constraints, quantity equation, land constraint, water requirement. Land means what? I wish to grow a lot of crops, but I don't have the land. Or I wish to constrain grow a lot of crops. I'm having land, but I may not have the water. Typical other things are how much groundwater I can withdraw. Similarly, I should say water quality also. I should say how much canal capacity water can be conveyed also. Similarly, the water cannot spill over the reservoir, top of the reservoir. Crop diversification means what? You cannot grow the crop, you should diversify your crops based on the requirements of the command area and the requirements of the people who are staying in the command area. So what I've done here, I try to there how many objective functions I'm having here? I'm having 3 objective functions. So what I've done here is solve these objective functions independently so that I know the lower and upper bounds, so that I can formulate my membership function. My membership function, whatever I've taken is same membership function, what I've shown you, a non-linear membership function, typically. So what exactly I'm doing now, once my model is ready with this type of constraints, what I told you, these are the crops. There are 14 crops in this slide, 2 more crops on this, 16 crops on there. So, sir, why should I solve? Someone should ask me, sir, why should I solve this objective function independently? At least I will know what is the impact of each objective function on the planning problems. And I will also know whether this particular problem fits to the multi-objective problem or not. That the reason whenever multi-objective problems are there, at least all of the problem objective functions independently. You will understand what is what. Another advantage is that you will know what is the highest value of the benefit and lowest value of the benefit. You will list some ranges. These ranges are useful to me when I am formulating my objective function values or the membership function values, in fact. So there are 16 crops are there. You can see labor employment, crop production, net benefits. You can see each optimization problem reacting differently. Is it right? React differently means what? But the paddy higher crops are higher acreage is coming because it is giving me the more money. Is it right? The more the paddy is the technically the revenue spinner. So you can see maize is growing in the crop production case because the more food production, the more advantage for the society. Simultaneously, you can see some crops you will have here. You can see chilies produces maximum labor employment. So that means each situations are different. But what is asked to me, sir, don't tell about individual objective functions. I'm talking about all 3 objective functions handling simultaneously. But what is happening now? I'm taking labor employment independently, ignoring other 2. Or I'm taking crop production, ignoring other 2. Or I'm taking net benefits, ignoring other 2. Is it right? But whenever somebody say, sir, solve the problem, is a fuzzy multi-objective problem, what is meaning of that? I'm telling that objective 1 and objective 2 and objective 3 to be satisfied simultaneously. With the same constraints, what is happening in the planning problem. Whenever I'm expecting that, for example, somebody say, sir, solve only labor employment problem independently, sir. That means what? Most of the degree of satisfaction may be 1. But when people say you should satisfy simultaneously, my degree of satisfaction, what is the lambda which I'm speaking, it will be never be 1. It will never be 1. It will be less than 1 only. So that is the reason we say here, what if what I've done here? I've taken, I think fuzzy optimization which I told you. What is solution? This solution is technically a multi-objective solution. That means why? It is nothing but what? Labor employment and crop production and the net benefits. Exactly the same pattern which I explained to you the numerical problem. You can see here, if you can see more, you will enjoy more. For example, labor employment, the benefits are this much, crop production this much, net benefit. You can see this value somewhere, compromise value. It is somewhere in between these 2 values, 3 values you can see here. Typically, what crop production here? 0.55, 0.78, 0.68, but it's coming in between somewhere 0.7, in between this. Typically, you can see here 46 here, 35 here, 40.43 here, but I'm able to get only 40.8. What is meaning of that? It is in, I never call this as a optimal solution. I will call this as a compromise solution. Because multi-objective problems, you never called the optimum. You use the word always, word compromise. Why compromise? I'm compromising only. I'm compromising only to get to, what is the compromise? Compromise is that I'm trying to satisfy all my objectives simultaneously, in fact. Simultaneously. So this is the way. Anybody interested in fuzzy logic, let me know. I will available 5 to 5:30 today for discussion. These areas you can do very easily if you have some understanding about the mathematics. You can apply to the same problem to water resources, transportation, any domain of your interest. What you require? Some objective function, some constraints, some bounds. Nothing else, nothing more than that. In fact, I prepared small research directions, it will take 2-3 minutes, not more than that. Whatever I shown a fuzzy logic type of problem, you can using, taking into consideration, even evaluation algorithms also. You can link to the problem to the data mining techniques also. In fact, you can assume that even the constraints are also right. Typically, you can also try to handle the problem in terms of a cluster validation techniques also. In fact, you can try same optimization in the climate change perspective also. Lot of things are waiting for you to do wonderful research in future. So I'm taking a break. I am 5 minutes, 5 more minutes left. Maybe some discussion can happen. Vipin?
Yes, sir.
Yeah. Okay. Problem equations. Yes. You're talking about these problem equations? Someone asking, someone asking about problem equations. Which problem equations?
Yeah,
Yeah.
Miss Anjali.
Prepared for a given problem, because
Okay.
once if I come to know for a problem how to prepare the equations, then for different problems I will able to define. Right now it is not
So which
possible
equation
for me
you
to
are used to
understand it.
optimize? You used to know
The
optimization
equations,
equations?
the next slide of this. Yes,
This
these
only?
equations, how
Yeah.
did you
Yeah, yeah.
plan,
Perfect,
and
perfect.
this one and the
Yeah, yeah,
previous slide.
yeah, perfect. It will 2 minutes. Okay. So first thing you should know how to formulate optimization equations. Okay. Then, so what is the first objective function? 4x1, 5x2. This is the objective function equation for the net benefits. Next is agri production, labor employment. These are my goals. And they told that this much fertilizer only available, this much. So these two are kept. So this is a typical optimization problem. People ask me to solve as a multi-objective problem. Again, I'm going back to how we have fixed the multi-objective problem. What is the multi-objective problem? I told you, maximization of lambda subjected to my membership function equations. Then,
So can you explain this, please?
yeah, I'm coming now. That only I'm explaining. I will explain the form of the numerical problem, easy for you to understand. Then, so what I've done here, whenever I want to apply a non type of what information I want to formulate the problem, what information I want, I know that I should know highest value of the objective function, lowest value of the objective function. That this much I require. What is Z here? My objective function value, my objective function equation. What is ZL value? The lowest value of the objective function value. What is ZU? Highest value of the objective function. That means what? Whenever I wish to solve using a membership function equation, I am supposed to have the lowest value of the objective function, highest value of the objective function. Simultaneously, equation of the objective function. If you remember this ZMN, what is Z? I told you Z is nothing but my objective function equation. ZL is lowest value which I am able to solve using objective function equation. Z is highest value. So if you remember this equation, I am going back to the numerical problem which I explained. So this is my numerical problem. This is my objective function 1, objective function 2, objective function 3. Then I wish to fit in the form of a membership function equation. So further what I have done here, so I try to solve a problem using single objective optimization of problems. You can see if you're solving using imagination of the benefits, highest value I got this much, lowest value this much. So this I am calling as ZU, this I am calling as the ZL. Typically, if you take the P tons production, lowest value this much, highest value this much. If we take labor and planet, lowest value this much, highest value this much. What is the Z here? Z is nothing but equation for Z1 is this much, Z2 this much, Z3 this much. If you remember this, all the relationships, I simply formatting magnitude of the lambda. So my first equation is what? Related to the benefits. What is my Z value for the benefits here? 4x1 plus 5x2. You can see here minus ZL. What is ZL in the case of the net benefits? 35, 32, 948. You can see here. By denominator, what denominator? Highest value, lowest value. What is highest, lowest value?
Understood, sir.
Okay.
Thank you.
Thank you. Any more?
So can you give me one such, maybe afterwards, some example with which we will able to practice for this?
Sure.
Yeah,
I'm
thank you.
sharing this slides to Mr. Vipin. You can try same problem also once again using the solvers.
Okay, thank you, sir.
Yeah. So someone asking me, yeah. So Fajra toolbox hands-on session would have been helped me. Some Shilpa Jane telling, I'm ready. If anybody wants to know, I can help you. Maybe you can talk with Mr. Vipin. Maybe sometime after 5 o'clock, I can help you Fajra toolbox. Maybe 10-15 minutes I can explain. Typically, someone asks how can use fuzzy logic to predict the feature load as from electrical background. So whatever I spoken about, this is basically for the in principle called the fuzzy optimization background. But you can also try. In fact, there are a number of rule based in the fuzzy logic called the input-output mapping, called Mandani, Sujan. All these approaches are there, which will help you to predict the feature load. So this is called this coming under heading of the fuzzy rule base. So that anybody interested, I can explain today at 5 o'clock, maybe after you all lectures are over. Yeah.
Yes, sir.
Any other discussion? Any doubts on the topic what we discussed till now?
Yes, anyone else? Any participant has any more questions? Okay. So on behalf of all the participants and organizing committee, I would like to thank Dr. K Shinawatra Raju sir for sparing his time. And despite all obstacles of adjusting to the new technology, he was always up for the challenge. So I thank you, sir.
Yeah. In fact, Microsoft Teams I used multiple times today. Only I faced difficulty.
Yes, sir. And as you have promised to the participants for a hands-on session, I will talk to you about that session again after the meeting.
Okay, thank you. Anybody have doubt, I will be available 5 to 5:30 for any discussion. 5:30 I have other work. After 5 to 5:30 I will be available. Thank you, Vipin. Take care.
Thank you, sir. Thank you, sir. I thank all the participants for joining in this session. We understand that we have been a little late and running behind the schedule. And because of technological problems, these things are coming up. Many of us are new to the system, including our speakers. So this is a difficulty we had to face. But I hope everything will be resolved today itself. And once we are used to the system, from tomorrow we'll be having the session right on time. So we'll take a short break. We have kept you for the lunch. Please come conclude your lunch in 30 minutes. And we'll start the next session at 3 in the Microsoft team. Google Meet we are keeping as a backup option. If things will become difficult in the Microsoft team, then we'll switch over to the Google Meet. So all are requested to please take lunch and join after the lunch from 3 p.m. for the next session in Microsoft team using the link already provided to you. Thank you, everyone.